Okay, this is very good. This is a good perspective here. All right. What I want to do is correct our attitude and to retrograde the spacecraft. Point the main engine in the direction of travel. And the reason the spacecrafts rotate a lot is to try to keep the heating equal on all parts. So what we're going to do now is burn while we're on this side of the moon. You can see where the line is here. We're going to burn the engine and bring our orbit down on the other side. Burning the engine in retrograde position will bring our orbit down on the other side. I think that's enough. Now I'm going to fast forward this, okay, to the other side of the moon, and then, we have to wait until we're above 30 kilometers. Right now we're at 22 kilometers. Well, I can get us up. Just going to boost the altitude a little bit. Okay, there we go. It's flying a little faster. Once we reach 30 kilometers, then we can fast forward a little bit. And I'm going to retrograde the spacecraft to the position of the direction, the main engine in the direction of travel. We've got a good orbit on that side. Looks like, okay. All right, we're at 31 kilometers. So we'll fast forward this a little bit. When we get to this side, I'm going to position the spacecraft prograde and burn the engine in the prograde attitude, and that will boost the orbit on the other side higher. Okay, now an engine burn. This is prograded. Burn the engine here. Watch the orbit rise on the other side. You can see that? There we go. That's good. Nice and circular. That's how you achieve a circular orbit with engine burns. Now we can just orbit the moon at this altitude. Oh, wait a minute. We're still pretty low here. At this altitude indefinitely. Making a video for my brother. So right now we're on the dark side, and be over on the light side very shortly. Reset that. There we go. Okay. We're coming into daylight here, I think. Yep, there we are. Coming into daylight. There we go. From here, I'm going to retrograde the spacecraft again. I'm making a video. I'm talking with my brother. Yeah. He's on the phone, and I'm making a video for him. Did you want something? Did you need something?
Yeah, I was learning how to climb that thing, and I was...
Okay, resume. There we go. So now, what are we at? Okay, 140 kilometers. What we can do here, this is actually about the right altitude where they would transfer control to the LEM from the command module. That's what it looks like when this app does it. And now we'll separate the two, undock. And we will retrograde the WEM. And this is for lunar descent, the descent, actual descent. We want to land about in the center of the daylight side. You can see our position now. We're moving slowly clockwise, but we also want to slow down the horizontal velocity. So we need to burn the engine to slow it down. We want to get the horizontal velocity down to a couple of hundred meters. And now we're at about 1,000. See how we're moving here. We're just burning in the direction of travel. You can actually see the moon will start to it's slowing down in the background as we slow down. But we're almost 70% fuel. I hope that I didn't start this too early and go through all our fuel. Shut down, and I'm going to. Okay, we're still retrograded. Good. Now, in order to drop a little faster, I can just rock the spacecraft. No, not in that direction. All right, how are we looking here? 400 meters per second and 128 kilometers. This is good. This should work really well. On our way down, we can adjust for horizontal velocity. We might even change. We might even reverse direction. It depends. The engines are real sensitive, and we have to really play it by ear or by eye. So it looks, right now we have very little forward velocity. Very little. We can drop a little faster. I think I will. I think I'll drop a little faster here. And we have some. We don't really have to make do any engine burns until we're down to about 20 kilometers at our present descent rate. So I think we'll be okay with that. It's hard to believe that I actually got the spacecraft all the way to the moon. I did, though. It really is simpler than it appears to be, at first. It's just really simple physics. You do one thing and something else reacts. Burn an engine and the spacecraft moves. And, along the way, you make mid-course corrections if your aim is not quite exact, and you can establish an orbit around an object like the moon. You can establish an orbit from almost any distance away from it by engine burning and mid-course corrections. So once you've established an orbit, there's no way out of it. You're going to go into orbit unless you do something to change that, fire the engines or whatever. But this is what makes orbits predictable. Okay, I'm going to rock it back a bit. Okay, we're at 30 kilometers. As we get closer, you'll eventually start thrusting the engine. Okay. Okay, our descent rate is good. I'm not going to mess with the forward velocity because we're not really aligned in the spacecraft. Not quite. The attitude isn't quite. Yeah, I can't really correct for this because spacecraft attitude. It's a weird attitude. Forget about that. Okay. All right. Yeah, that looks about right. Okay. Well, yeah, it's closer anyway. We can, yeah, we can actually gain a little altitude and enough to rock this thing in the right direction to try and slow the thing down. Yeah, it's not right. If I were able to pay a little more attention, I could have handled this a little better. Shadow soon. Here we are. That's the shadow. There we are, bro. We made it.